Okay, in the last video we went over how when you change the number of protons, you change the element type. Okay, so this is my super famous, super tech-based example of how radioactive decay works. Okay, so we'll post it here, and this is my little intro. Okay, so I'm going to tear this, post it in half. Okay, and then I'm going to tear it in half again. And then I'm going to tear it in half again. When do I actually run out of paper? The answer is never, because if I have a piece to tear in half, I'll always have the other piece to tear in half. Okay, so bringing that into context with the with one we went over during the last video. Let's say I have a radioactive element here. This is a full sample of radioactive element. Okay, and let's say that this decays in half. So now this is, I don't know, element A, and now this over here is element B. Okay, so this element has literally changed into this one by throwing a proton away. Okay, so let's say that this process of decaying in half takes 10,000 years. Okay, so if I look at a sample, all right, and I look at the ratio of A to B, and the ratio is 1 to 1. I know it's split in half once. I know this rock sample is 10,000 years old. Now this A element is going to break apart again, right? It's going to decay into element B again. Now how long does this take to break in half again? Well, it takes 10,000 years. Okay, every time it decays in half, it takes 10,000 years, and that's the half-life of that radioactive element. So this was 10,000 years, this is 10,000 years, so now we know that the rock sample is 20,000 years old. And then it takes, this would be A, this would be B. So you look at the ratio of A to B, and you can tell how many times that radioactive element has decayed in half. In this case, I've got 10,000, 20,000, 30,000. Okay, so this rock sample, we would say, is 30,000 years old because it's decayed in half 3 times. Okay, that's how we can tell the absolute age of rocks, or the how many years, actual years, this rock has been here. Okay, so there is a lab that you would have done in class. I want to show you that lab. I'm going to show it to you. I'm going to actually do the lab and then show you the data and how it works. Okay, so this is what you would have done. You would have gotten a tray. Okay, oh, the lighting is really bad. Let's see here. Is that better? Yeah. You would have gotten a tray, and you would have gotten kernels, and these corn kernels represent radioactive elements. Okay, so I'm going to sprinkle it on here, and there's 50 in here. I counted them. So what you would do is shake the box, and this would be on one of the blue trays. So this is a little bubbly. It's just a box that I had in the backyard. Okay, so there we go. Now we have element A, element AB, and element ABC. So the corn kernel, a little point on them. So what I'm going to do is take out all the corn kernels that point toward A. So you see how that one points toward A? So I'm going to take that one out. Okay, and this one right here points toward A. So I'm going to pull that one out. And the ones that I'm pulling out represent elements that have decayed into the other element. This one right here is pointing toward A. and then I would keep on doing that. Okay, so this is turn 1. Okay, so this one right here, this one right here, and any more down at the bottom. I'll say this one is, and these 3, and that looks like that's pretty much it. Well, no, that's C. Okay, so what I would have done, or what you would have done, okay, is you take your tray, okay, you put that off to the side for a second, and this would be a lab sheet, obviously, but trial 1, we started with 50 kernels. Okay, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11. So what do I have left? Okay, I've got 39. Okay, I would put those kernels off to the side. Okay, and I would do it again. So I would take this tray and I would shake it, and I would pull out all of the kernels that point toward A again, and I would put my data on the sheet. Okay, so I'm going to go ahead and actually do the lab and give you a set of data, and then explain how this models radioactive decay. Okay, so I'll see you in a little bit.